Far beyond the orbit of Neptune, there's a region of space most people will never think about. It is silent, it is frozen, and it is almost completely unknown in detail. We call it the Kuiper Belt. At first glance, it sounds harmless, just a collection of icy rocks floating in deep space. But when you look closer, when you understand its scale, its distance, and what it hides, the picture becomes far more unsettling. This is not just empty space. It is a massive, distant boundary filled with ancient remnants from the birth of our solar system. Objects that have never been touched by sunlight in billions of years, drifting in darkness, following slow and unpredictable paths. And here is what makes it even more interesting. Some of these objects can be influenced, disturbed, and even sent toward the inner solar system, meaning what happens out there does not always stay out there. In this video, we are going to explore the Kuiper Belt in a calm and scientific way, but also understand why scientists still consider it one of the most mysterious and least understood regions around our sun. To understand the Kuiper Belt, we first need to understand where it exists. It begins just beyond the orbit of Neptune, the eighth planet in our solar system. This region stretches outward for billions of kilometers, forming a wide disk-like zone filled with icy bodies, dwarf planets, and leftover material from the early solar system. Some of the most well-known objects in this region include Pluto, once considered the ninth planet, now classified as a dwarf planet. But Pluto is only one of many. In fact, scientists believe there are millions of objects in the Kuiper Belt, most of them too small and too far away to be clearly observed. This region is not empty. It is crowded with ancient debris, and yet, despite its size, despite its importance, we have only explored a very small fraction of it directly. Most of what we know comes from distant observations and limited spacecraft data. This means a large part of the Kuiper Belt remains unseen, and anything that remains unseen naturally becomes a source of curiosity, and sometimes concern. The Kuiper Belt is often described as a leftover region, a place where material from the formation of the solar system still exists. When the sun formed 4.6 billion years ago, not all the gas and dust became planets. Some of it was pushed outward into the farthest edges of the solar system. Over time, this material formed icy bodies, ranging from small rocks to dwarf planets. These objects are composed mostly of frozen water-methane isomonia rock and dust mixtures. Because of the extreme cold, these materials remain solid and unchanged for billions of years. Scientists believe the Kuiper Belt is like a frozen archive of the early solar system, a preserved record of how planets and space material originally formed. But there is something important to understand. We do not see the Kuiper Belt directly like we see planets. Instead, we detect it indirectly by observing how light reflects from distant objects or how their gravity affects nearby bodies. Even today, many objects in this region are still being discovered. Some are large enough to be considered dwarf planets. Others are only a few kilometers wide, and many are still completely unknown. The more we study this region, the more we realize one thing clearly. We are looking at a part of space that is both ancient and incomplete in our understanding. The Kuiper Belt exists in one of the most extreme environments in the solar system. At this distance, sunlight is extremely weak. In fact, if you were standing on an object in the Kuiper Belt, the sun would appear only as a very bright star in the sky. It would not provide warmth in any meaningful way. Temperatures in this region can drop to around minus 200 degrees Celsius or lower. At these temperatures, gases freeze instantly, ice becomes rock hard, and movement is extremely slow. This is a world of permanent darkness and deep cold. There is no atmosphere, no weather, no sound, only silence and distance. This extreme environment is part of what makes the Kuiper Belt so difficult to study. Spacecraft traveling there take many years to reach even a small portion of it. And once they arrive, they can only observe a tiny fraction at a time. This is why most of the region remains unexplored. Not because it is unimportant, but because it is simply too far. The result is a vast cosmic region that exists on the edge of our understanding. One of the most interesting aspects of the Kuiper Belt is the presence of unusual objects. Some of these bodies do not behave exactly as expected. Their orbits are sometimes irregular. Their compositions are not always consistent. And in some cases, their movement suggests gravitational influences we are still trying to fully understand. For example, there are dwarf planets in this region that challenge classification. Some are large, icy, and spherical, while others are elongated or irregular in shape. There are also objects with unexpected brightness patterns, suggesting surface changes or unknown materials. In addition, some Kuiper Belt objects appear to have tilted or unusual orbital paths. These irregularities raise scientific questions. Are these effects caused by past collisions? Are they influenced by unseen gravitational forces? Or are they simply part of a complex system we do not yet fully understand? At this stage, science does not have all the answers, and that uncertainty is what makes the region so fascinating, because every new discovery seems to reveal another layer of complexity. Kuiper Belt and comet threats to Earth. The Kuiper Belt is not just a distant region of ice and rock. It also plays a role in shaping activity within the inner solar system. Occasionally, objects from the Kuiper Belt are disturbed by gravitational forces. When this happens, they can be pushed inward toward the sun. Some of these objects become comets. These comets can travel across the solar system, sometimes even entering the inner planet's region. While most of them burn up or pass safely by, the fact that they originate from such a distant and unpredictable region adds a layer of scientific interest. It is important to understand that this is a natural process, not a sudden danger, but a slow, gravitational interaction over long periods of time. However, it reminds us of something important. Even the outer edges of the solar system are not completely disconnected from Earth. What happens far away can eventually influence what happens closer to home. What science still cannot explain. Despite decades of research, there is still much we do not know about the Kuiper Belt. We have only sent one major spacecraft through this region, New Horizons, and even that mission was extremely limited in scope. Most of the Kuiper Belt remains unvisited, unmapped, and unseen in detail. Scientists still cannot fully explain the exact distribution of objects, some unusual orbital patterns, potential hidden influences on movement, the full range of composition across the region. There are also theoretical ideas about distant gravitational effects that may influence outer solar system objects, but these remain under study. The truth is simple. We have mapped planets. We have studied moons. But the outer boundary of our solar system is still largely a mystery, and the Kuiper Belt is a major part of that mystery. Beyond the Kuiper Belt lies an even more distant region, a theoretical boundary known as the Oort cloud. Unlike the Kuiper Belt, the Oort cloud has never been directly observed. It is believed to be a vast spherical shell of icy objects surrounding the solar system. If the Kuiper Belt is the outer edge of a disk, the Oort cloud is the outer shell of that structure. This region is thought to be the origin point of many long-period comets. But because it is so far away, it remains entirely theoretical. This means that beyond the Kuiper Belt, our understanding becomes even more uncertain. We move from observed science into deep scientific hypothesis. When we look at the Kuiper Belt as a whole, it becomes more than just a region of space. It becomes a reminder of how little we truly see. We have explored planets, mapped moons, and sent spacecraft beyond the known boundaries of the inner solar system. But even now, the outer edges remain quiet, distant, and largely unknown. The Kuiper Belt is not dangerous in the traditional sense, but it is a symbol of something much larger. The limits of human observation, the boundaries of exploration, and the vastness of space that still surrounds us. Every object in that region has been traveling in silence for billions of years, unchanged, uninterrupted, and largely unseen. And perhaps that is what makes it so powerful. Not fear, but perspective. If you found this journey through the Kuiper Belt interesting, you may also want to explore other regions of deep space that remain largely unknown to science. Because every time we look further into space, we are reminded of how much there still is to discover, and how small our understanding truly is in the vast structure of the universe. Thank you for watching.